Good morning, everyone. Welcome back to step 1994. This is question number 5 from the paper. Okay, so we have a parabola with equation y equals x squared. And the points P and Q with coordinates P, P squared, and Q squared respectively move on the parabola in such a way that the angle POQ is always right. Is always a right angle, so always 90 degrees. And we asked, so we have two parts of the questions. The first part is to find and sketch the locus of the midpoint R of the chord PQ. Okay, interesting. I mean, I think the first thing that needs to be cleared up here is, what do you really mean by this, right? So we have to sketch something. Again, I know what that means, but what do I mean by the locus of the midpoint R of the chord PQ? So P and Q are points that are changing around my parabola, right? So if I draw, or they can change, right? I want to make them change and see what happens, basically. So if I just get my parabola, so it's going to be y equals x squared, so it's going to be sort of like this kind of shape. And I take 2 points in that parabola, so maybe this is my point P, right? Because any point in that parabola will be such that its y value is just the x value squared, right? By definition of the function. And maybe my point Q is over here somewhere, right? So that's Q squared. And obviously the condition is such that the angle here, so the angle between, so where O is the origin, right? So O is just the point 0, 0. That's also on the parabola, right? Since 0 squared, just 0. And we're told that the angle between so this angle here, if I can just draw it. No, it's not letting me do it. Hold on. Okay. So what we care about is sort of this angle here. If it lets me finish off. So QO, so we're just sort of constructing a line connecting those 2 points in the parabola. But we also want another line connecting O and P. And then we want to find the angle between those two lines. Effectively. That's what this question is telling us about. So maybe, hold on, let me see if I can get this better. Okay, so it's decided to not let me do anything to it. It's stubborn and doesn't want me to interact with it. Okay, there we go. That's better. So yeah, why is it doing this? There we go. So perhaps the angle. So what we really care about is this angle here, right? This angle sort of between those two lines. So the first line is connecting the point Q and the origin, and the second line is connecting the origin and point P. And we're interested in the angle between those two lines, right? Or those two line segments. So I guess the sort of the thing that we want is we want this to be 90 degrees. So we want this angle here to be right. Obviously, it doesn't look right in my case, but it should be. If sort of the points P and Q are chosen correctly, right? And the point of this question is we're always making the correct choice. So somehow we know which 2 points P and Q are such that that angle will be 90 degrees. And as we move those points around, right? As I move those points around, because it's not just going to be one. It's not just going to be sort of one pair of points. It's going to be lots of different points because I can move both Q and P. So if I can move both of those points around, I'm going to get a family of points such that this is true, such that the angle I get is 90 degrees. And I'm interested in how my midpoint between those 2 points changes effectively as I move those points around the parabola. So the locus of the midpoint R of the chord PQ is just me effectively drawing the set of all my midpoints effectively, right? So I'm interested in what effectively maybe my midpoint at some point will be the coordinate 0, 1. Maybe at another point it'll be the coordinate 1, 5. But I want to be able to effectively connect all those midpoints into sort of one curve to tell me to basically describe all the possible midpoints in one. as opposed to me just listing them out one by one. I can draw a curve to connect them together and talk about all the possibilities all at once. And there'll be infinitely many, right? So this will give me a nice clean curve, as we'll see. But how do we actually sort of get that curve? What even is that curve? And that's a little bit trickier. Okay, so that's the point of this question. Is we have a curve representing all the possibilities of our midpoint as these 2 points P and Q shift. And I want to know what that curve is as a function of x, effectively. Okay. So, right. Well, first things first, we know this is 90 degrees, right? So because we know that's 90 degrees, these two lines are going to be perpendicular, right? Because that's effectively what it means to be perpendicular, is that you have two lines that are 90 degrees to one another. Which means that the gradient of one is the negative reciprocal of the gradient of the other, right? So if I can calculate the gradient of this line on the right, which I can quite easily, right? Because it's just going to be my change in y, so p squared divided by p, right? My change in x. So I don't know if it's going to, okay, that worked. So this change in y here, that's just going to be p squared. No, that's not what I want to do. Okay, yeah, this is not going to be nice, but you guys can see hopefully what I'm talking about. This here is just going to be p squared, and this change in x here is just going to be p. So the gradient of my line OP, right, is going to be p squared over p. So if I say m representing the gradient of OP, it's just going to be p squared divided by p, right? Obviously p can't be 0, but effectively you can just pick any other point on that parabola. And I mean, if it was 0, then obviously it'd just be a point, so it wouldn't make any sense. So this just gives me p, right? So my gradient of OP is p. So as long as that gradient is defined and I don't have just a singular point, then I know that the gradient of OQ is going to be the negative reciprocal of that by the sort of fact that this angle between them is 90. So I guess then I know that the gradient of OQ is minus 1 over p. Right. But I can also work out the gradient of Q in the same way that I worked out that gradient, right? In other words, so I'll just do it like this. In other words, we know that our change in y is just going to be q squared, and our change in x is just q. So again, this is just going to be q squared divided by q. So minus 1 over p is q squared divided by q, which if q isn't 0, and I can actually, and that sort of line actually exists, then I know that this will just be q, right? So minus 1 over p is q. So really my points, so I have my points, so I have my coordinates, let's say p, which is just going to be given by p and p squared as we had at the beginning of the question, and q, which I can now rewrite as minus 1 over p and 1 over p squared, since minus 1 over p times minus 1 over p just gives you 1 over p squared, right? So now I have my two coordinates in terms of p, and I'm interested in my chord PQ. So I'm interested in this line that connects those two things, right? And what's the midpoint of that going to be, right? Maybe here it looks like it's going to be somewhere over here. But as I move those points, right, I'm going to get sort of infinitely many different midpoints, and I want to see if I can graph sort of a function that represents each of those midpoints. What would it be? Okay. Well, I mean, we can do this relatively systematically at this point, right? So I guess we know that the midpoint of PQ, so the midpoint of PQ is just going to be, so PQ, just going to be equal to P minus 1 over P divided by 2, right? And then also, so that's going to be our x coordinate, and our y coordinate is going to be p squared plus 1 over p squared divided by 2, right? So what's this actually going to give us? So it's going to give us p squared, so p minus 1 over p It's just p squared divided by p minus 1 divided by p. So p squared minus 1 divided by p divided by 2. So p squared minus 1 divided by 2p. And what's this going to be in the right-hand side? Well, it's going to be p to the 4 plus 1 divided by 2p squared. Right? So... Okay, interesting. So I guess how am I going to really think about this? How is my y value changing as a function of my x value here? Really? Because this is my midpoint, right? But as I give you different values of p, my midpoint clearly shifts. But how is it really shifting, right? As a function of x? Well, remember, this is just my x value. This is my y value. So how is this related to this, basically? Okay, that's difficult. I mean, we noticed that this squared is kind of similar to this. So maybe you try out something with that. So I guess trying out... So if y was actually just x squared, so if the midpoint's y value was just the x value, its x value squared, that's how it was related, then p squared minus 1 over 2p all squared should be equal to p to the 4 plus 1 over 2p squared, right? But that's not quite true, although what actually is this thing evaluated? But this isn't quite true. So what actually is this thing on the left-hand side evaluated, right? Well, it's p squared minus 1 over 2p all squared. So this just gives me p to the 4 minus 2p squared, right, plus 1, divided by 4p squared, right? So it's just effectively p to the 4 plus 1, again, minus 2p squared, divided by 4p squared. Okay. But again, this is kind of... I mean, you can clearly see this is not exactly the same as that, but it does look very similar. And I guess, how exactly is this similar? It's kind of difficult. It's kind of tricky to put your finger on. But maybe I can try to subtract... maybe I can try and multiply this by 2. Right? Maybe I can try and multiply this by 2. And if I multiply this by 2, then I can get a 2p squared on this denominator, right? Which seems closer to what I had up here than what I have right now. So maybe this is just going to be x squared, right? But maybe we want to consider, so I guess considering 2x squared, then we get 2 times p to the 4 plus 1 minus 2p squared over 4p squared, right? Which gives us 2p to the 4, right? Or maybe I can even say it like this, right? The best way to say it is just to sort of, the best thing to do here is to just divide top and bottom by 2. So if I'm doing 2 times all that, then I'm just going to get p to the 4 plus 1 minus 2p squared divided by 2p squared, right? Since I'm just multiplying the top by 2, and I can just cancel out a 2 from the top and bottom there, effectively. So what I end up getting is p to the 4 plus 1 minus 2p squared over 2p squared. And this is just the same as p to the 4 plus 1 over 2p squared, right? Minus 1. And this here is just our y value from before. So this is just equal to y minus 1. Okay. So actually what I have now is a function of x, right? I have 2x squared So 2x squared is equal to y minus 1, where sort of the coordinate xy represents the midpoint of PQ. Represents the midpoint of PQ. Right. And so my function, so basically my locus of the midpoint R of chord PQ is just going to be the function y equals 2x squared plus 1. Right? And what this means is that effectively, as I change my points P and Q, my midpoint will change to some other value on that curve, right? So every single possible midpoint, the set of all my midpoints, is described by a function of x, right? Y is equal to 2x squared plus 1. So if I just like look at each point on that parabola, then I notice that effectively for some value of P and Q that gives me 90 degrees, I get that point in the parabola as a midpoint of my chord PQ. So I guess this is what really this function is telling us. And so let's actually now just graph it. Well, graphing it is probably not the problem. It was really getting to that point which is the hardest. If I do, so obviously the plus 1 means that I'm going to have sort of my minimum here. So at 0, 1. And I guess we can just try plotting a few values. So x is equal to 1, we get 3. We know the rough shape of this will be, like a parabola. So this will give you, so for minus 1, again, you get 3, and it's symmetric. So you can just sort of imagine that it would have a shape kind of like this, right? So it's going to be like that kind of thing. I know that's not perfect, but that makes sense. Then obviously our initial function, y is equal to x squared, is something like this. So that is y equals 2x squared plus 1. And that completes the first part of the question. Okay, what about the second part of the question though? So find and sketch the locus of the point T where the tangents to the parabola at P and Q intersect. Okay, that sounds also quite tricky. But we do know some stuff about tangents, right? We know some stuff about derivatives. So this is going to be hopefully not too bad, but we know that the derivative, first of all, with respect to x of x squared is just 2x. We know that. So I know that the derivative of x squared evaluated at x is equal to p is just equal to 2p, right? The same, we also know that derivative of x squared evaluated at minus 1 over p, right, which is the x value of our q, of our point q, x equal to minus 1 over p, is just going to be equal to minus 2 over p. Okay. And so what we're interested in really is the locus of the point T where the tangents to the parabola at P and Q intersect. So now instead of looking at sort of the curve that describes all the possible midpoints, looking at the curve that describes all the possible intersection points of the tangents at P and Q, right? So it's just a different curve, but the same kind of idea. So we need to somehow, again, find the relationship between the x and y coordinate. We need to, first of all, find some sort of representation for the x and y coordinates of that intersection point, and then see how the x and y coordinates are related, right? By which function relates them. So how can I do this? Okay. Well, I'm thinking I can set up the equation for my tangent. It's just a line, right? So if my tangent has gradient 2p and passes through the point p squared, then it must be of the form y is equal to 2px minus p squared, right? Because if I plug x is equal to p in there, then I get 2p squared minus p squared is equal to p squared. So it has to be effectively the line with this gradient that passes through this point, which uniquely identifies the line that we want, which is y is equal to 2px minus p squared, right? So that's the first. So we can call that y1. That's our first tangent. So that's tangent at p, right? If I want to find my tangent at q, I guess I do a similar thing, except this has to pass through the point minus 1 over p. Sorry for my pen. 1 over p squared. So this time it's going to be like y2 is equal to minus 2 over px, I guess, minus 1 over p squared. Because if I plug in minus 1 over p, I get 2 over p squared minus 1 over p squared, which gives me 1 over p squared. And that's the value of my y that I want. So that's my tangent at q, right? So that's my tangent at q. Tangent at q. And now I need to find the points of intersection of these two lines. So I just equate them, right? Because when their y values are equal, then they'll be intersecting, right? So, okay. We have 2px minus p squared is equal to minus 2 over px minus 1 over p squared. And so now we need to solve for x, right? And that will be the x coordinate of our intersection point. And then I guess from there we can solve for the y coordinate of our intersection point. Okay, so this is going to give me 2p add 2 over p multiplied by x is equal to p squared minus 1 over p squared. So if I just sort of like clean this up, I get 2p squared plus 2 over p squared multiplied by, sorry, it's going sort of below where when I'm recording. 2p squared plus 2 over p squared times x is equal to p to the 4 minus 1 over p squared, which is just the same thing as p squared plus 1 multiplied by p squared minus 1 divided by p squared, right? So now I can solve for x by dividing both sides by 2p squared plus 2 divided by p squared. So this just gives me that x is equal to sort of p squared plus 1 multiplied by p squared minus 1 divided by p squared times, right, because we're dividing by 2p squared plus 2 over p squared, so it's going to be times the reciprocal of that, times p squared over 2 times p squared plus 1. So this cancels, this cancels, this cancels, this cancels, and I just get that this implies that x is equal to p squared minus 1 divided by 2. So that's my x coordinate. So then what the hell is my y coordinate going to be? Well, we can just plug it into y1 or any of the two lines. They should be the same, right? Because that's where they're intersecting. So that's my x coordinate. So my y coordinate, okay, so my y coord at the point of intersection, is just going to be, how do I say this? Is effectively going to be y equals 2p, so this is just me plugging my x value back into this y1 here. I could also plug it into y2, but I'll plug it into y1, because why not? So 2p multiplied by p squared minus 1, right? Divided by 2, and then I guess we do minus p squared, right? That's our y1. So obviously these two cancel. And 2p times p squared minus 1 over 2 minus p squared. So this just gives me p cubed. Just gives me p cubed minus p squared, which is just p cubed minus 2p squared. Okay, so I just realized that I made a mistake because I was confused there for a second, and I've realized what that mistake is. So if any of you guys saw this, I apologize. This should not be a p squared. This should be a p. Simply because when we went from this step to this step, I multiplied this by p over p. So it should be a 2p squared instead of it should be a 2p squared over p, not a 2p squared over p squared. Okay, fine. And so then that gives me, then that gives me this multiplied by p divided by p squared. So I end up getting p squared minus 1 divided by 2p. And so this is a 2p, and so this p also cancels out. And I get something a lot nicer, which is exactly that Sorry, I should also zoom out. So yeah, this should be a p squared minus 1 divided by 2p instead, right? Because instead of multiplying by p squared over that, I'm multiplying by p over that. And so then what I end up having is y is equal to p squared minus 1 minus p squared, right? Which is just going to be minus 1. So that's a lot nicer than what we had at the beginning. So my point of intersection, I guess they called it t, intersection t is equal to, well, has coordinates, has coords, what was it? P squared minus 1 over 2p minus 1, right? And as I vary my p, this can be basically any real number I want it to be, right? Because p squared minus 1, well, p squared minus 1 is going to be between minus 1 and infinity. But if it's sort of anything positive, I can make my p as negative as I want, right? Because then I'm dividing by 2p, as long as it's not 0. But I could also make 0 by letting p equal 1, so 1 squared minus 1 divided by 2 is just 0, right? So I can get every single real number here, effectively. And so what that means is, so effectively, so locus of point of intersection, so locus of point t is just the line y is equal to minus 1. Simply because, right, as I change p, right, as I change my points p and q, right, my midpoint will always be given by this. So it's sort of depending on what the coordinate, x coordinate of my point p is. Obviously my point q has to change as well. But the y value is always going to be minus 1, right? So as I change my 2 points, the point of intersection of their tangents will always have y coordinate minus 1. But the x-coordinate could change to be any real number I want it to be. And so effectively, sort of the set of all points of intersection of those tangents will just be the line y equals minus 1, because my x value can be anything. And so, just like that, we are finished. And I need to sketch it, actually, I just realized. But sketching the line y equals 1 isn't too bad. We can go back up here and just sketch that, right? So I guess we can just say this is going to be the line y equals minus 1. So something like that, right? That's going to be an extending in both directions. So that there is going to be the line y is equal to minus 1. Okay, let's just check that we've done everything. So find and sketch the locus of the midpoint R of chord PQ. We've done that. Find and sketch the locus of the point T where the tangents to the parabola at point P and Q intersect. Points P and Q intersect. Nice. Okay, awesome. Thank you guys for watching.